Hello everyone. Today we will discuss the next topic of our microcontroller and embedded system, that is input-output port structure. ये जो क्वेश्चन है that comes under the marks 5 या तो 5 मार्क्स का आ जाता है, कई बार 10 मार्क्स का भी जो है ये क्वेश्चन आ सकता है हमें। तो इनपुट आउटपुट पोर्ट स्ट्रक्चर वैसे तो हमने ऑलरेडी पढ़ लिया हुआ है कि हमारे पास जो चार मैं यहाँ पे डिस्कस करता हूँ। हाँ जी, तो हमारे पास बेसिकली चार पोर्ट्स होते हैं, ठीक है। एज वी ऑलरेडी डिस्कस, ऑल माइक्रोकंट्रोलर हैव फोर, जो 8051 सीरीज है उसके चार आईओ पोर्ट्स होते हैं विच आर नेम्ड एज P0, P1, P2 एंड P3, ईच कंप्राइजिंग 8 बिट्स विच कैन बी कॉन्फ़िगर्ड एज इनपुट और आउटपुट। हर पोर्ट जो है वो 8 बिट का होता है और हर किसी का अपना SFR में एड्रेस है जहाँ पे उसका जो डाटा सेव होता है। Accordingly, in total of 32 input-output lines enabling the microcontroller to be connected to peripheral device are available for use. Basically, total जो 32 pins होती हैं, मतलब 8 बिट्स अगर एक पोर्ट का होगा तो हमारे पास टोटल 32 पिंस जो है दैट इज मेंट फॉर द पेरिफेरल डिवाइस दैट कनेक्ट्स विद द दैट कनेक्ट्स द माइक्रोकंट्रोलर विद द आउटसाइड वर्ल्ड, राइट। तो ये इसका काम होता है इनपुट आउटपुट पोर्ट का, एक्सटर्नल वर्ल्ड के साथ मिलाता है माइक्रोकंट्रोलर को। अब इनके फीचर्स, कॉमन फीचर्स क्या है? ईच पोर्ट हैज 8 पिंस, वी ऑलरेडी नो। Thus the four ports jointly comprise 32 pins. All ports are bidirectional. Bidirectional का मीन्स क्या होता है? It can be work as input port, it can be work as output port, ठीक है। तो ये डाटा को ले जाने और डाटा को लेके आने के काम आता है, so it is known as bidirectional port. All the ports have bidirectional ports, right? They are constructed with the D type output latch. अब ये आगे ये जो चीजें हैं इसके बारे में हम डिस्कस करेंगे। जो सारे पोर्ट्स हैं they are having D output latch, मतलब इसमें जो D फ्लिप फ्लॉप लगा हुआ है जो कि हमें 1 और 0 आउटपुट देने या 1 और 0 सिग्नल देने के काम आती है। तो वी विल सी हर पिन पे अपना एक डी लैच लगा होता है, राइट। दे हैव आउटपुट ड्राइवर्स एंड इनपुट बफर्स, और इसमें जो है वो आउटपुट ड्राइवर्स और सिग्नल को भेजने के लिए और सिग्नल को रिसीव करने के लिए जो बफर्स होते हैं दे आर अटैच्ड विद द एवरी पोर्ट, राइट। We can modify their function using software and hardware that they connect to. हमें पता है कि चार में से जो तीन पोर्ट्स होते हैं they are having dual functions, right? And one is having only one function, that is port 1. तो हम मतलब इनके जो functions हैं they can be modified with the help of software and hardware. We will learn about these things in the future slides, right? All the ports are configured as input ports on reset. अब सारी जो ports हैं वो by default अगर हम reset कर दे तो वो सारी ports जो हैं they will be considered as input ports, ठीक है। मतलब उन सब के पास जो on the reset value आएगी that will be 1. हर पोर्ट के हर बिट पे 1 वैल्यू जो है वो रीसेट प्रेस करने के बाद आएगी एंड दैट इज कॉन्फ़िगर्ड एज इनपुट पोर्ट। To configure port as an input port, one must be written to that port. मतलब अगर हमें किसी भी पोर्ट को इनपुट पोर्ट बनाना है तो उस पोर्ट पे हमें 1 जो है वो मेंशन करना पड़ेगा, तो वो जो है पोर्ट क्या बन जाएगा? इनपुट पोर्ट बन जाएगा। मतलब इनपुट पिन पे जो भी सिग्नल आएगा they will get as a input, right? And to configure it as an output port, the 0 must be written to it. अगर हम उस पोर्ट को 0 लिख देंगे 00H, that time it will considered as a output port और हम जो सिग्नल है वो माइक्रोकंट्रोलर से भेजेंगे to the external peripheral, right? So these were the features. आगे बढ़ते हैं हम पोर्ट 0 के बारे में। This is gonna be a very interesting lecture, क्योंकि इसमें मैंने बहुत सारी वीडियोस भी ऐड की हुई हैं। आपको उस वीडियोस के जरिए जो है वो समझाया जाएगा कि हाउ दीज पोर्ट्स वर्क, राइट। सो पोर्ट 0 एनिमेशन वीडियोस होंगी वो। पोर्ट 0, पहले इसके बारे में थोड़ी डेफिनेशन पढ़ लेते हैं। दिस इज एन इनपुट आउटपुट पोर्ट 0। इट इज अ डुअल फंक्शन पोर्ट। इसके दो काम होते हैं। वी कैन सी दिस ऑन द कंट्रोलर पिन्स आल्सो, ठीक है। माइक्रो जो पोर्ट 0 है that is given on the right side of the DIP package, ठीक है। So it is having dual function. It not works as input output port but also works as bidirectional address, that is lower byte of address slash data bus. तो ये जो है ये AD0 से AD7 bus का भी काम करती है, which is having multiplexed address, lower byte of address as well as 8 bits of data bus. कब यूज होती है एज एड्रेस स्लैश डाटा बस? व्हेन एक्सटर्नल मेमोरी इज यूज्ड विद द 8051, राइट। That means whenever there is an internal memory accessing there will be no use of these address and data bus because these are having internal address and data bus. But अगर हम external memory add कर देते हैं whether ROM or RAM, then we need some address bits and data bus. So that time port 0 will be considered as the address slash data bus, right? So this port is also called bit addressable. अब ये port की बात नहीं कर रहा मैं, चारों ports को अगर मैं बोलूँ तो we can call it as a bit addressable because as such pin of the port, each pin of the port has its own specific address, that is port 0.0 to port 0.7. हर port का अपना एक address होगा जो कि 0.0 से लेके 0.7 तक चलेगा, right? And the SFR address of the port is 80H. ठीक है, ये already हम कल SFR में पढ़ चुके थे last topic में, right? अब इसकी जो कंस्ट्रक्शन है उसमें इन्होंने देखो बताया हुआ है पोर्ट 0 हैज अ डी टाइप लैच, एक तो इसका डी टाइप लैच लगा होगा, यूनिडायरेक्शनल बफर होंगे इसके पास, ठीक है, रीड और आउटपुट ड्राइवर का, एंड टू एफईटीज एट ईच पिन, दो एफईटीज लगे होंगे हर पिन के ऊपर, राइट? इट डज नॉट हैव एन इंटरनल पुल अप रजिस्टर, और ये अकेला ऐसा पोर्ट होगा जिसमें पुल अप रजिस्टर इंटरनली नहीं होंगे. वी हैव टू कनेक्टेड इट external pull-up resistors with the port 0, right? An external pull-up resistor is needed when port 0 is defined as a output port, और तभी यूज होगा जब हम इसको एज अ आउटपुट पोर्ट यूज करेंगे, राइट? और वो क्या क्यों होगा वो हम इस जो है आगे एनिमेशन में देखेंगे. आपको इंटरनल पुल अप रजिस्टर का भी कॉन्सेप्ट समझ आ जाएगा इसमें, तो आप ध्यान से देखिए, जो जो भी वो बताएंगे आपको आप साथ में नोट करते रहना. इट विल बी वेरी इंटरेस्टिंग टॉपिक, राइट? तो ये इसका जो है कंस्ट्रक्शन डायग्राम है. अब इसमें देखिए हमने जो आज तक ये बात नहीं की थी हमने पोर्ट 0 के, अब हम हर किसी का स्कीमेटिक डायग्राम देखेंगे, इंटरनल स्ट्रक्चर. तो ये दिस इज अ डी टाइप लैच which is connected with the port 0, ठीक है, हर बिट पे अपना डी टाइप लैच होगा, और ये डी टाइप लैच के आगे जो है these are called unidirectional buffers. एक तो रीड लैच है, एक रीड पिन है, ठीक है, और यहाँ से हम इसको इनेबल करते हैं इस पोर्ट को, और इंटरनल बस से हम यहाँ पे सिग्नल देते हैं 0 और 1, ठीक है. अब 0 और 1 जो भी देंगे हम दैट विल कंसिडर्ड एज इनपुट और आउटपुट, ठीक है. और ये एड्रेस और डाटा बस इसका डुअल फंक्शन है. जब हम इसको यहाँ से पिन देंगे तो दैट टाइम हमें जो ये एड्रेस और डाटा बस सिलेक्ट करनी है, ये कहाँ से सिलेक्ट होगी, दैट इज फ्रॉम द कंट्रोल पिन. अगर हम कंट्रोल पिन को 0 कर देंगे तो दैट टाइम द मक्स विल बी कनेक्टेड टू दिस साइड, मतलब ये एड्रेस और डाटा बस को स्विच ऑफ कर देगी. बट अगर हम कंट्रोल पिन को 1 देंगे दैट टाइम एड्रेस एंड डाटा बस जो है वो सिलेक्ट हो जाएंगी एंड मक्स विल बी related to this pin, and the output will be address and data bus, and that time the D type latch will be cut off from the port 0, right? So ये port X की पिन है, मतलब यहाँ पे हमें एज अ इनपुट और आउटपुट जो भी हमें चाहिए वो यहाँ पे मिलेगी हमें, राइट? तो इसकी जो एनिमेशन है उसके बारे में हम बात करते हैं.
We know that port We know that port 0 can be used for input-output operations or as a low-order address and data bus for external memory. Here we will see how port 0 is used for input operations. When port 0 is used for input operations, a 1 has to be written onto the latch of port 0. And one more important point here is the control signal has to be 0. It has to be 0 when port 0 is used for input-output operations, and it has to be 1 when it is used for external memory. So in this case it has to be 0. And coming back here, a 1 has to be written onto the latch, and when we enable this latch, the data is visible at the output. We get 1, and this is the complement, we get 0. And this is a 2:1 mux. And when the control signal is 0, it allows this signal to pass through. And when the control signal is 1, it allows this signal to pass through. And in this case, as the control signal is 0, it allows the output of the latch to pass through, which is 0. And we get 0 over here. And coming here, we know that the control signal is 0, and 0 ending with any other thing is 0 again. So we get 0 here also. And we know that these are the FETs and they act as switches. A low, a low to an FET, that means it acts as an open circuit. When FETs act as an open circuit, that means they don't allow anything to pass through. And if I measure the voltage at this point, it is going to be high impedance state. It is at high impedance state because this point is neither connected to 1 nor connected to 0. It is at the third state, which is nothing but high impedance state. Now port 0 is ready to act as an input. An external device, say for example, maybe an ADC or maybe a keypad. If they want to write something, say if they want to write 0, they will overwrite the high impedance state and write 0. And we will read that state through this buffer. And if they want to write 1, they will overwrite the high impedance state and they write 1. And we can read that data through this buffer. Here we will see how to make port 0 as an output. When port 0 is used for output operations, a 0 has to be written onto the latch. And when I enable this latch, the data is visible at the output, which is 0. And I get 1 here as a complement. And we know that the control signal has to be 0 for input-output operations. So it is 0 here. The multiplexer will allow this signal to pass through. I get 1 here. As my control signal is 0, I get 0 here. Now port 0 is ready to act as an output. Now we'll see how to output 0 and how to output 1. This 0 was written to make port 0 as an output. Now we will write the real data 0. I'll write 0, and when I enable the latch, the data is visible at the output. This is the complement, and I get 1 here, I get 0 here. A 0 to an FET makes it as an open switch. This is open. And a high to an FET makes it a closed switch. This is a closed switch. So if I go and measure the value at this point, it is going to be 0. Because this point is connected to ground through this FET. So I get 0 here. In this way we can output 0. Now we will see how to output 1. Before that I'll just erase these things out. Yes. Now I'll write 1 because I want to output 1. I'll write 1 and I'll get 1 here. This is the complement. I get 0. And the control signal is again 0, so mux allows this signal to pass through and I get 0 here. As my control signal is 0, I get 0 here. So now both the FETs are open switch. Now if I go and measure the value at this point, it is going to be at high impedance state. This is because the point is neither connected to VCC nor connected to ground. We get into a third state which is called high impedance state. We were supposed to get 1, but instead of that we are getting into a high impedance state. So what we can do here is I will add one pull-up resistor. So what does this pull-up resistor do is it pulls the value of this point to VCC. Now, if I go and measure the value at this point, it is going to be 1. Now, the problem is solved. And one more important point with respect to this pull-up resistor is it pulls, it, it only pulls the value of high impedance state to VCC. It absolutely doesn't have any role if the point is at fixed logic. Say if the point is at 0 or 1, it absolutely doesn't have any role. Because in the previous case, we were supposed to get 0. In that case, this pull-up resistor doesn't pull 0 to 1. It has its effect. It has its effect only when the point is at high impedance state. So in this way, we are outputting 1. Now we know how to make port 0 as an output and how to output 0 and 1. Here we will see how port 0 is used for external memory. When port 0 is used for external memory, the control signal has to be 1 so that it allows address and data bit to pass through. First we'll consider address bit as 1. Here we will get 0 as the inverted data and we get 0 here. Here we'll get 1 ending with 1 is 1. So that this is a closed switch, this is an open switch. So if I go and measure the value at this point, it is going to be 1, which is the value of VCC because of this closed switch. Now we will see how to output 0. For that I'll just erase these things out. Yes, we'll consider address bit as 0 and we get 1 here as the inverted data. We will get 1 here. 0 ending with 1 will get 0 here. So that this is an open switch. This is a closed switch. If I go and measure the value at this point, it is going to be 0 because this point is connected to ground through the closed switch. In this way, we output 0. When the address has been formed and latched by address latch enable, the same bus turns around to become a data bus. So this was about port 0 used for external memory.
Right. तो अभी आपने वीडियो में देखा कि हाउ वी कैन यूज दिस पोर्ट as a IO port and as well as the address bus and slash data bus. ठीक है, तो उन्होंने बहुत अच्छे तरीके से समझाया कि जब हम कंट्रोल पिन को 0 करेंगे and that time the it will act as a input output port. ठीक है, बट क्या देंगे, सिग्नल 0 देंगे और 1 देंगे, तो उस पर डिपेंड करता है हमारा इनपुट या आउटपुट बन रहा है। आई होप आपको समझ आ गया होगा, अगर नहीं आया होगा आप दोबारा से वीडियो देख लेना, बहुत अच्छे से आपको दोबारा जो कॉपी पे नोट करके समझ आ जाएगा। नेक्स्ट बात करते हैं हम इनपुट पोर्ट 1 की। दिस इज एन इनपुट आउटपुट पोर्ट 1, इट डज नॉट हैव डुअल फंक्शन। अब ये ओनली पोर्ट है in the controller 8051 which is having only one function. It is also bit addressable, so the port address will be port 1.0 to port 1.7 तक अपनी अपनी पिन्स होती है। The address of SFR address of this port is port 90H, right? अब इसके पास क्या है अपना, इट इज हैविंग अ डी लैच, 2 यूनिडायरेक्शनल बफर, 1 एफईटी एंड 1 इंटरनल पुल अप रजिस्टर एट ईच पिन, राइट? तो ये इसकी जो कंस्ट्रक्शन है, इसमें देखिए आप देख सकते हैं कि देयर इज नो काइंड ऑफ कंट्रोल फंक्शन, जस्ट बीसीसी के साथ इंटरनल पुल अप रजिस्टर लगा है। तो वो उसको फ्लोटिंग पॉइंट से बचाने के लिए, हाई इंपीडेंस स्टेट से बचाने के लिए इसको 1 जो है वो डिक्लेयर करता है, राइट? तो इसमें बाकी सारा कुछ सेम है। एक एफईटी लगा है 2 एफईटी की जगह। तो इसकी जो हम एनिमेशन है वो स्टार्ट करेंगे, राइट? उससे पहले एक सेकेंड, मैं यहाँ से एरो प्रेस कर दो अब, राइट?
Welcome to the video lecture on port 1 of 8051. Unlike port 0, port 1 has no dual functions. It can only be used for input operations and output operations. as it doesn't have any dual functions, I don't need a mux over here. So previously the output of a latch has been connected through a mux to an FET. So now I don't need any mux as a control logic. The output of the latch can be directly connected to an FET. Now we'll see how port 1 is used as an input operation. So whenever port 1 is used for input operations, a 1 has to be written onto the latch. So I'll write 1, and when I enable this latch, the 1 is visible at the output, and the complement of that I'll get 0 at Q bar, and a 0 to an FET makes it an open switch. So FET here is used as a switch here, so 0 to an FET makes it open switch. And if I read over here, it is neither connected to 0 nor connected to VCC, and it is at the third state known as high impedance state. And that high impedance state is being pulled up by this pull up resistor, and it makes it 1. Now port 1 is ready to act as an input device. Any external device, say for example a keypad, it wants to write 0 onto that. Whenever it wants to write 0, it overwrites this high impedance state, and it writes 0 over here, and the same 0 can be read by this buffer, So for example, now keypad wants to write 1 onto that. So what it does is it simply leaves this high impedance state, because this high impedance state is being pulled up by this pull up resistor, and in that way it can write 1. So this is how port 1 can be used as an input operation. Now we'll see how port 1 can be used as an output device. Whenever we use port 1 as an output device, a 0 has to be written onto the latch. So I'll write 0 onto that, and I enable this latch. When I enable the latch, I'll get 0 at the output, and complement of that I'll get 1 over here. So 1, 2 and FET makes it a closed switch. Now FET is closed and VCC is connected to ground. Now port 1 is ready to act as an output device. Now I'll write the real data. Whatever 0 initially was written, it was to make port 1 work like an output device. So now I'll write the real data. I'll write 0 here, and when I enable the latch, I'll get 0 over here at the output, and the complement of that I'll get 1 here, and 1 makes this FET a closed switch. That means VCC is connected to ground, and I'll get 0 over here. This is how port 1 outputs 0. Now we'll see how port 1 outputs a data 1. So I'll just erase this stuff. Yes, now I want to output 1, so I'll write 1. As I have written 1, and when I enable this latch, I'll get 1 at the output, and complement of that I'll get 0 over here. So 0 to FET makes it an open switch. So FET is an open switch now, and if I go and measure the value over here, it is neither 0 nor 1. Again, it is at the third state, which is known as high impedance state. So to overcome this high impedance state, I have connected one pull up resistor here, and that pulls up the state to high, to VCC 1. So in that way we output 1 at the output. This is how port 1 can be used for input and output operation. Thanks for watching.
Right. So how port 1 works we can see over here. ठीक है जी, पोर्ट 1 की एनिमेशन थी ये. नेक्स्ट हम बात करते हैं पोर्ट 2 की. तो पोर्ट 2 के बारे में अगेन इट इज एन इनपुट एंड आउटपुट पोर्ट 2. पोर्ट 2 डू हैव डुअल फंक्शन, ये भी डुअल फंक्शन परफॉर्म करता है. इट इज यूज्ड इन कंजक्शन विद द पोर्ट 0. जैसे पोर्ट 0 था वो लोअर एड्रेस बाइट, लोअर एड्रेस जो है लोअर बाइट ऑफ एड्रेस यूज होता था 80 से 87. ठीक है जी. ऐसे ही पोर्ट 2 जो है वो पोर्ट 0 के साथ यूज होगा, बट इट कंसिस्ट ऑफ हायर बाइट ऑफ एड्रेस. ठीक है जी, बाय पोर्ट 2. This port is also got bit addressable, and the bits are having port 2.02, port 2.7, and the address of port 2 is A0H. ठीक है, in the SFR. और इसमें जो construction है, that is port 2 has a D-type latch, one FET, one internal pull-up resistor, two unidirectional buffer, and a control logic block. Right? अब इसमें जो इसकी जो है इसमें हमें एक FET की जरूरत पड़ी है, बाकी जो दूसरा FET है उसकी जगह हमने इंटरनल पुल अप रेजिस्टर लगा दिया. ठीक है, तो कंट्रोल पोर्ट जो है वो डायरेक्ट यहाँ से इंटरनल पुल अप रजिस्टर को दे दिया है. बाकी इसमें मक्स भी यूज हो रहा है जो कि पोर्ट 1 में नहीं यूज हो रहा था. दिस मक्स इज यूज टू switching used to do the switching between that IO function as well as address function. Right? तो इसके बारे में पढ़ते हैं हम.
So we'll study port 2 of 8051. We know that port 2 of 8051 can be used for input and output operations, and it can also be used for external memory access. Whenever we want port 2 for input and output operations, the operation remains same as it was explained in port 0 of 8051. Whenever I want port 2 to work like an input, a 1 has to be written onto the latch, and if I want port 2 to work like an output, a 0 has to be written onto the latch. For more explanation on input and output operations, I request you to watch a video on port 0 of 8051 from Eng classes, wherein the input and output operations have been explained in great detail. Here we'll consider external memory access. We know that 8051 has 4 kilobytes of internal ROM, and if we feel that we want to connect an external ROM, we can connect an external ROM. But the next question is, how do I access that external ROM? So that accessing can be done from port 2. Port 2 provides the higher order address byte of the address, external address, along with port 0. That means port 0 provides the lower order address, that is A0 to A7. I can get this address from port 0, and port 2 provides the higher order address, that is A8 to A15. I can get this address from port 2. So along with port 0 and port 2, I can get 16-bit of address. In that way I can address the external memory. So this is all about port 2 of 8051. So in brief, port 2 can be used for input and output operations, very much similar to port 0 of 8051. Along with this, it has one more function, external memory access. Port 2 provides external memory access. It provides the external address from A8 to A15, that is higher order address byte, along with port 0, which provides lower order address bus. So this is all about port 2 of 8051. Thanks for watching.
Right. So इसमें हमें पता चल गया कि how it works as a external memory access and how बाकी इसकी जो working है that is same as port 0. ठीक है कि कैसे वो as a उसको control bit को 0 और 1 जो है अगर करेंगे तो वो it will switch between the mux. ठीक है, तो वो as a address bus और as a IO function use होगा. बाकी जो functioning है that is same as an input और output port. Right. आगे पढ़ते हैं हम port 3 के बारे में. This is an input and output port 3. It is also called bit addressable port. और इसकी जो पिन है यहाँ पे port 3.0 से port 3.7 कर लीजिए. ठीक है जी. By mistake ये रह गया port 2.0. Address is B0H, right? और जो construction है that is having D-type latch. In addition to that, it has 3 unidirectional buffers. वो क्यों है वो हम पढ़ेंगे. FET with an internal pull-up resistor. एक FET लगा है, internal pull-up resistor लगे हैं. Additionally, it also has NAND gate connected to the FET. ठीक है. It is also having a dual function. और जो इनके functions हैं वो सारे यहाँ पे दिए हुए हैं. ये एड्रेस और डाटा बस की तरह काम नहीं करेगा, बट एवरी ईच बिट ऑफ दिस पोर्ट विल हैव अनदर फंक्शन, जैसे कि पोर्ट 3.0 दैट इज that works as a RxD, that works as a serial input port, and 3.1 works as a TXD, that is serial output port. 3.2 works as external input INT 0 bar. 3.3 works as a external interrupt 1, that is INT 1 bar. 3.4 works as a timer 0, ठीक है जी. 3.5 works as a timer 1, right external input, and 3.6 works as a write latch, where the external data memory will be written. 3.1 works as a read bar, from where the external data memory will be read, right? So this will be the different dual functions of port 3. अब इसकी जो वर्किंग एनिमेशन है, पहले उससे पहले हम इसका जो कंस्ट्रक्शन है वो देख लीजिए. यहाँ पे हमें 3 बफर दिए हुए हैं. इट इज हैविंग एन एडिशनल बफर, राइट? और वो एडिशनल बफर क्यों दिया? बिकॉज इट इज हैविंग एन एडिशनल फंक्शन दैट इज डिफरेंट फ्रॉम एड्रेस एंड डाटा, राइट? और इसमें एक एफईडी के साथ एक नैंड गेट लगा हुआ है, जो कि हमें अल्टरनेट आउटपुट फंक्शन करने में हेल्प करता है, राइट? अब इसकी जो वर्किंग है दैट विल बी we will watch in the video.
We'll study port 3 of 8051. Port 3 of 8051 can be used for input and output operations. So whenever it is used for input operation, a 1 has to be written onto the latch, and whenever it is used for output operations, a 0 has to be written onto latch. I request everyone to watch a video on port 1 of 8051 to understand input and output operations of port 3 in much detail, wherein in that video I have explained input and output operations in great detail. Along though port 3 can be configured for input and output operations, that is not how the normally it is being used for. Along with that, it also has got other functionalities. Port 3 is bit addressable. That means I can address each and every bit of port 3. So these are the additional functionalities. Bit 0 and bit 1 of port 3 can be used for serial data communications, and the SFR associated with that is yes buffer. Similarly, pin number 2 and 3 of port 3 can be used for external interrupts, and the SFRs associated with them are the TCON. And pin numbers 4 and 5 can be used for timers, and SFRs associated with them is TMOD. Similarly, pin number 6 and 7 of port 3 can be used for read and write signal whenever we are accessing external memory. So this is all about port 3 of 8051. To brief it up, very much similar to port 1, port 3 can also be used for input and output operations. Along with that, port 3 has got additional functionalities. Each and every bit of port 3 can be addressed, that is, it is bit addressable. So all 8 pins have got 8 different operations. So this is all about port 3 of 8051. Thanks for watching.
So this was port 3 animation. अब हमारा जो पोर्ट आईओ पोर्ट का 4 आईओ पोर्ट्स हैं हमारे, उन सब का स्ट्रक्चर एंड वर्किंग एज वेल वो हमने कवर कर लिया. आप इस वीडियो को आराम से देख सकते हैं, कोई हरी नहीं है. इसको चाहे आप पूरा दिन लेके आराम से विद द ब्रेक्स आप इसको देखिए, ठीक है? और जो कोई भी क्वेरीज होगी वो हम ऑनलाइन सेशन में पूरी कर लेंगे, राइट? सो थैंक यू.